Hey Algebra 2, what I have for you today is the Chapter 10 review, kind of a scenario of what's going on. I'm not going to do all the problems, but I'm going to do some of them, run through them quickly so you can get some help here. So 1 and 2, graphing the functions. You can obviously put this into your calculator and then graph it. Or what I like to think about is that I have, let me get my little cursor here, come on. I have my A, which is my starting value, which is my 2, and my growth rate is 3. So if I start at 2, that's my y-intercept, and then I'll grow by 3 from there. Same thing with the other one, even though it's DK, I'll start at 6, so that's my y-intercept, and then I'll go down by dividing by 3. Both of their domains and ranges are the same, all real numbers, and y greater than should not be equal to. I made a mistake on here. Not equal to. No. Because we have an asymptote coming along at y equals 0 on both of them. My mistake. Next, I would like to talk about number 5 and 6. You are given the a value just from looking at that right there. That gives you the intercept, so you know your a value is -2. From there, you can plug it into your basic equation, y equals a times b to the x. So I plug my a in. Then you can use your point to plug in for the x and y coordinates, y and x, and ultimately solve for b. At this point here, the reason why I got 3 is I did the cube root of 27, or that's the same thing as doing 27 to the 1/3. Something to think about, but it's 3. What number times itself is 3 times is 27. Same thing for number 6. All right, next page. So for number 7 and 8, I mean, actually, honestly, all the way through 14, I really think about how we can use change of base here. For 7 and 8, you're just asked to rewrite it in its logarithmic form. Base of the exponent is base of the log. Same thing for 9 and 10. Base of the log is base of the exponent to rewrite it. And then you come down here and say, okay, all right, now I can do change of base. Number 11, you don't need to do change of base because it's already to a tenth, so you can actually just crank that into your calculator. But for all 4 of these, you can do the change of base, or I rewrote the top 2 in their exponential form. That's fine as well. So I did top 2 as exponentials, bottom 2 as change of base. You can decide what you would like to do. Moving on to 15 and 16 and 17. 16 and 17 actually are a lot alike. You're going to want to rewrite this as either a log. This one is actually 15 is a great one to rewrite as a log. Log base 9 of 1/81. And then you can do change of base from there if you do not realize that you want this to be, and actually this should not be -1/2. It should be -2. I did this kind of fast. 16 though, if I have a 2 as my base here, it would be great if I could have a 2 as my base for this one. So I'm going to convert the 4 to become something with a 2 as the base. So 4 is 2 squared, so I can convert 4 to be 2 squared. Once I do that, then I can cancel out my 2s, my bases of 2s, and then distribute, oh, daughter's coughing, distribute the 2. So once you distribute the 2, you'll get 6x equals 10x minus 4. Similar to number 17, I made 49 7 to the something, and so in this case it was 7 squared. Then I could cancel out my 7s and then rock and roll from there. 19, 20, change of base. I think you're starting to get the picture here, people. Okay, now we start to talk about canceling out logs, not just canceling out exponential bases. For 21, you see that you have a log base 8 right away, so you're able to just cancel those right away, leaving 3y minus 1 equals y plus 5. However, on number 22, it's not one single base equals one single base. So we need to combine these somehow in order to have one single base. Well, there's three important rules or properties that we learned for logs. The first one is that addition always becomes multiplication and vice versa. So for this addition, we can combine these into one single log using multiplication. So we can say log base 6 of 16c equals log base 6 of 80. Then we're allowed to cancel, leaving 16c equals 80. For number 23, I have no idea why I missed it, but this is the second rule that we learned, and that is that second rule, subtraction becomes division and vice versa. So for number 23, we can combine these into one log using division. Log base 2 of 4 divided by x plus 3 equals log base 2 of 8. Then we can cancel our logs, leaving 4 over x plus 3 equals 8. All right, and then the last one represented is I call the drop it like it's hot or pick it up property, and that's where an exponent could be outside and it's actually supposed to be up with the 4. So also this 2 was really an exponent with the k. So what that allows me to do is bring my exponent up, and then I have one single log equals one single log. 4 cubed equals k squared. And then that's something that I can solve right there. All right, 29, 30 are kind of challenging problems here. Well, 29 not really. I just converted that to the logarithmic form and then used change of base. 30 though, it's hard to convert this to logarithmic form because you're thinking, I don't understand, because if I took this side and made it base 6, but this side would be a base 8, and I was confused. So that's why I wrote log on both the sides here. I took the log of both sides. Then once I did that, I used my drop it like it's hot, and I dropped my exponents down in front, leaving me with 3y times log of 6 and y minus 1 times the log of 8. You need to be very careful and make sure you have parentheses here because you're going to distribute. Now this is about to get very ugly. This is just a problem that, it's fun to think about, but it's kind of an ugly problem. So you'll distribute your log of 8 because that's just a number, giving you y times log of 8 minus log of 8. Then you've got these two things equal to each other, kind of a messy little majiggy, but it's right here on the side. I moved my y log of 8 over with subtraction, and that's what you're seeing right here. Then I noticed both the terms have a y in them, and I factored that out. Once I had that factored out, I said, okay, this guy's just a number, so I'm going to divide both sides by him. So what I didn't write, ultimately at the end, I have y equals log of 8 divided by 3 log 6 minus log 8, that glamorous, gorgeous thing, which apparently gives me 0.63. Yuck. One that I really like more than that is number 31. I changed that to its logarithmic form. Base of the exponent is base of the log. Used change of base, and then was able to crank through from there. That one's a little bit prettier. All right, to comment on the next page, all natural logs and e's just kind of cancel each other out. So anytime that you have an e and a natural log, they get to just, yay, disappear. I remember both of these are equal to x, so that's where that random weird x came from. Other than that, they are solved just like regular logs. Natural logs are regular logs. They're just lazy people logs that we didn't feel like writing another thing. Remember, another thing that's really appropriate. Another base. Log. Base E is just natural log. Fancy time. All right, last slide. When we are doing word problems, if we see the term compounded continuously, that means that we're doing it as often as possible. Therefore, our wonderful E has come into play here, and so we're going to use PERT. Make sure you put it in your calculator, put parentheses around the exponents. If we do not see a PERT and we just see that we are growing, we're going to use P times 1 plus R to the t. Remember that 1 represents 100% because you have to keep 100%, in this case of the $2,000, and then add on more. When you're solving this, since you have an unknown in the exponent, I did absolutely convert to log and use change of base. Similarly, for number 46, another growth rate, 1 plus the rate, etc. All right, then, I think we're good for number 47 and 48. They seem pretty manageable as well. 49, because the car is depreciating by 25%, that means it's keeping 75% of its value. That is represented in this formula. But I like it better for you to understand what's going on. If you're depreciating, you lose 25% of its value. We want to know how much of its value it's keeping, and that's why it's 1 minus. All right, half-life. So you're going to set up your half-life. Your rate is 1/2. Surprise, because it's half-life. So I wrote it kind of small, but here's your equation for half-life. As I'm filling it out, I start with 40 milligrams. It's a half-life. Now, each half-life is 5,730 years. I'm going to decay for 17,190 years. So how many half-lives is that? That's 3 half-lives, and so that is the t that goes into there. And you'll see that I have 5 milligrams left over. We're 52. For 52, you're just solving for the rate instead. Only kind of difference you have here when you set it up, you're good to go there. You're at some point going to have to solve this. It's like because we've been doing exponents, we now forget how to do anything else with exponents, you know, instead of taking the log. To undo this 10th here, you need to do the 10th root. That yellow doesn't really show up. Let me get a different color. You need to do the 10th root, okay, of 1.42. So in your calculator, do 10th root of 1.42 or do 1.42 to the 1/10. Similarly on the next problem with the 6th root. All right, guys, I think that's it for the review. Woo, woo. Good luck, good luck, good luck, good luck. We'll talk more about what's on the test and what you can expect tomorrow during class.